Hello gentlemen, the purpose of this video is to talk about functions. We're particularly going to be concentrating on how to find the domain of a function and what it means to be a function. And you already saw some examples of a function when you did linear equations, but we're going to expand a little bit and we're going to talk a little bit more generally. So let's get this started. Let's talk about a function. When we talk about functions, I think you guys have probably seen this idea of a function machine. And so we're going to talk about that a little bit. Whereas we put something into that function, and that's called the domain. Put the domain into the function, and the function does something to the value, and we get out the range. So we have the domain, which is our input, and we get the range, which is the output. The domain, members of the domain are called the independent variable. Okay? And each member of the domain gets mapped to exactly one member of the range. So if I put in a number here, I only get one thing out in the range. That's important to understand. That's one of the key characteristics of a function. If I got more than one out, then I wouldn't be a function. Okay, so each member of the domain gets mapped to exactly one member of the range. The range is the dependent variable. Okay, it depends upon what I put in here. Note though that two or more elements in the domain may be matched with the same element in the range. What that means, if I put in 1 here, for example, and I get 5 out, and I put in -1 and I get 5 out, that's okay, all right, because each member of the domain got one mapping, and it can be mapped to the same thing. A number in the range can have two different members of the domain associated with it. Okay, let's do a little practice here with this. Let's take our function. Here's our function machine. Our function machine here is going to be f of x equals x squared plus 2. And let's see how it works. So if I plug the number 5 in here, it tells me that I square 5, 25 plus 2, and my function machine should give me 27. And it does. Try a different one. 3. 3 squared, 9 plus 2 should give me 11. It does. Plug in 1. 1 squared plus 3 gives me 3. Okay, it's working. Let's try -1. I get 3 again. So the question is, no, both 1 and -1 were mapped to 3. Is this still a function? Is this okay? Or did I break some rule? The answer is it is still a function. Remember, to be a function, each member of the domain must be mapped to exactly one member of the range. We did. 1 got a value of 3. -1 got a value of 3. That's okay. They only got one value. More than one element in the domain can map to the same member of the range. And that's what happened here. Both 1 and -1 were mapped to 3, but that's okay. Let's look at another one. See what happens here. If I plug in 5, I don't know what my function is here. Let's see what happens. If I get 5, I get 27. Okay, no problem. If I plug in 3, I get, okay, all of a sudden it's spitting out 3 things at me. 3, 23, and 35. This time 3 is mapped to these different values. Is this still a function? The answer here is no. And that's because each member of the domain must be mapped to exactly one member of the range. This is key, fellas. Make sure you understand that. Let's talk a little bit more about domain. Domain is what we can plug into our function so that the function produces a result. And as an example, let's use our function. Our function is going to be defined, f of x is going to be defined as 1 over x squared minus 1. And let's plug in some values and let's see what happens to with our function machine here. If I plug in 2, I get 1 over 2 squared, which is 4. 4 minus 1 is 3, so I get 1/3. Okay, that worked well. Let's try again. Let's plug in 3. 1 over 3 squared. 3 squared minus 1 is 8, so 1 over 8. There it is. Perfect. Let's plug in 1 and let's see what happens. 1 over 1 squared minus 1, 0 on the bottom. Uh-oh. Problem. That didn't work. Let's try a different number. Let's try -1. If I plug in -1, I get 1 over -1 squared is 1. 1 minus 1, again we get 0. Oh, it didn't work. Alright, what's going on? Looks like we broke our machine. So, what's happened here? Note that 1 and -1 caused our function machine to blow up. Why? Well, if you look at it, it's because they both produce a value of 0 in the denominator. And we know that division by 0 is not possible. Okay, that makes sense. So what do we conclude off of that? We conclude that the domain of the function is all real numbers except for plus or minus 1. I can't have division by 0. But if I plug in any other number other than 1 or negative 1, this function machine is going to work great. And so what I have to do is stipulate that this function is not defined for plus or minus 1, and it's not in our domain. Okay? Let's talk a little bit more about domain. Domain is a set of all values of the independent variable for which the function is defined. What can I plug into my function machine to make it work? Here are some domain concerns that we need to be careful of. Division by 0. We can't have division by 0. We just saw what happens. The machine blows up. The other one we got to really pay attention to is negative value under an even radical. For example, if I had the square root of x, or the 4th root, or the 6th root, or the 8th root of x, then if I tried to plug in negative 1 here, it's not going to work. I can't take the square root of a negative number and get a real value back. And so my domain here, again, this is a bracket notation, is 0 to infinity. Any positive number or any number greater than or equal to 0 will work. The closed bracket here, closed bracket means it's including 0. If it was an open bracket, as we'll see in another example, it would be not including that value. All right, so this could be a 6 or 2 or 4, 4th root of x, it doesn't matter. Note that a cube root, I can take the cube root of a negative number. The cube root of negative 8 is negative 2. So that's okay. It's just when these are even. Let's look at an example. It says find the domain of the function here. All right, this function looks pretty complicated, but let's take a look at it. We have two things we need to be concerned about here, you should know. The two things we should be concerned about is one, having a negative value under this radical, and the other one is division by 0. We have to be careful of both of those things in this particular problem. So let's look at those, and basically what we want to be true is that this value under the radical, this x squared minus 9, if it's greater than 0, then I'll be fine. Note that if it was just radical, let me just get my pen, if it was just this function, if I had f of x, whoop, I'm sorry, whoop. No, let's go back. Sorry about that, fellas. Let's look at this. No, I want you to note a couple things here. If this was, here we go, this was f of x is just equal to the square root of x squared minus 9. Then when I write this, then I could have had an equal sign, because this can equal 0. And the reason why it's just greater than in this particular example is because I can't divide by 0. Okay, so make sure you understand that. If I keep going here, that means I want x squared to be greater than 9. And that means x is going to be greater than 3, or x is going to be less than negative 3. Both of those situations will satisfy that equation. And therefore my domain is going to be from negative infinity to negative 3. Note the open bracket here. That means that negative 3 is not included. If I plugged in negative 3, I would get 0 in my denominator, and then I would be the function would not be defined. In union with, or also this interval here, 3 to infinity. Okay, so there is a pretty good example that looks at both of those. Here are some practice problems for this stuff. I want you guys to read section 1.4 again. Pay attention to these examples. They're good. They're worthwhile. Here's some problems that should help you. These should not take you very long, especially these ones in the beginning. Just to get the idea about domain, about functions, and what's a function, what's not a function. Okay, again, email me if you have any questions. But to summarize, a function, when we talk about a function, we're talking about inputting one value, the independent variable. That's my domain. What can I plug in? In order to be a function, each member of the domain gets mapped to exactly one member of the range. The range is the output, or the dependent variable. Okay? If a function maps a member of the domain to more than one point in the range, it's not a function. Okay, that's important to know. right? And we talk about domain concerns. Our big domain concerns are going to be division by 0 when our denominator is 0, and the other big one is going to be a negative number underneath an even radical, like the square root of -5. Doesn't work. Causes the function machine to blow up. All right. So any questions, gentlemen, make sure you email me. These are important concepts. We're going to come back to domain and range often throughout the course of this class, and certainly in calculus next year. All right. Have a good day.